Okay, guys. This is the vacuum solenoid which is installed in the car. The car has this vacuum solenoid for the turbo, and you saw the live data parameter of the solenoid, and the vacuum was allowed to the turbo wastegate was just about 10 or 10 inch of Hg. This is the donated one, and I just bought from a scrapyard today, and now I'm going to check the resistance, both vacuum solenoid resistance, and compare to each other, and then I'm going to show you the donated vacuum solenoid parameter as well, connected to the vacuum gauge, and also the control line connected to the scope as well. Now I'm going to check the resistance of the solenoid, and I've got the O2 data specification for the, as you can see here, turbocharger. What is it's not clear. Okay, turbocharger valve position actuator, and pin 1 and 2 disconnected. It has to be 16 ohms, and also I tested the second turbocharger when position actuator 1 and earth, ignition on 11 to 14 volt. That was right. And also you saw the control side voltage while the engine was idling, and also with the high rev meter of approximately 33,000 rpm. And so here is a test at component. We are going to check the resistance, and at the bottom line here they say checking supply voltage test at harness multiplier. So we have done the second one. Now I'm going to compare the two resistance, the two vacuum solenoid resisting together. Here we have got at manufacturer specification 16 ohms. Okay, now I'm going to check the resistance of the original one which was installed in the car. Yeah, it's 16.2 of ohm. This is the one which is installed the car, and now I'm going to check the donated vacuum solenoid resistance. Okay, this is the donated vacuum solenoid, and I'm going to check this one resistance. It's the same, it's 16.5. So what am I going to do? I'm going to install the donated one, and then connect the vacuum gauge to it. At the same time read the scope meter data which will be taken from the control wire of the vacuum solenoid. Now I'm going to start the engine. See, we have approximately got 12 inch of hg vacuum, and the boost air pressure is 98 kilopascal, and boost pressure command is 10 kilopascal, and the engine speed is 834 or something like that. Now I'm going to increase the engine RPM to 3000 RPM. It's 2600. And we've got 110 kilopascal. The command is the same as the boost pressure. So we have got, and also the engine starts smoking. I can show you. To 8. RPM, and we have got 106, 108, and here we have got approximately place vacuum now. If I rev the car, as you can see from here, now the vacuum stays at 12.5. Changes will not take place in the boost pressure while just slowly depressing the accelerator pedal, but if you snap on the accelerator pedal or the throttle, then you see the boost pressure also jumps up, the boost pressure sensor voltages also increases, and also the boost pressure command increases as well. See, watch. Watch the vacuum gauge. Vacuum is increased by the ECU instead of, if I slowly depressing the accelerator pedal, watch, the vacuum is decreasing. See, vacuum is decreasing. If I snap the accelerator pedal, look, the vacuum is increases. Here the boost pressure sensor voltage also increases. So I'm going to take to a test drive the car and see, because when the car is stationary, so the electronic control module restricts the engine RPM. If that's the reason, it could be, but otherwise. So the difference is here. When I install the donated vacuum solenoid, when I depressed or snap the accelerator pedal, the vacuum increases. But the previous one, with the original vacuum solenoid of the car, when I was pressing the accelerator pedal, the vacuum did not increase. So instead it was decreasing. Okay, I'm going to take it to a test drive, and then if I was able, I will record the test drive procedure, and with the scanner connected, I will if I get able, and I will record the live data as well. So I will let you know. This is the changed vacuum solenoid. Let's see how the vacuum gauge is acting when I press the accelerator pedal. Now I'm going to hold at 3000 RPM for approximately 2 or 3 minutes. Engine at 3000 RPM, and see, this is the pulse weight modulation, the on time of the signal, and this is the voltage that we can have at the control wire, which is 6.67, and this is the vacuum. We have got approximately more than 12, but with the previous one, when we hold at still accelerated 3000 RPM, so the vacuum gauge was coming back to 5 inch of vacuum. If I snap the acceleration pedal, you will see changes in the pulse width modulation, the on time of the signal. You watch, and I'm going to snap the pedal down. Okay, we have fixed the problem. Now I'm going to check if there is any DTCA stored in the memory. There is no fault code stored in the memory, so that's a good result from our investigation. Just to let you know guys, that do not rely on only on wave pattern and also resistance of the something like this, the vacuum solenoid, because the resistance was the same as I changed with the another one, not new one but second hand one, and also the wave pattern which you saw, that was also the same, and the voltage at the pin 91 of DC or the control wire was the same at idle, and also The only thing which was different when you were pressing the accelerator pedal, so the solenoid which was faulty it was acting differently than the one we have changed. So you need to approach to the you need to approach to problem diagnosing very comprehensively. You do not lie on just one test. You need to test the system, that whatever test is necessary. For this one, for example, if we didn't have the vacuum gauge, we couldn't find the problem, because we see the difference in the vacuum that which was releasing by the vacuum solenoid was different than the one which was faulty. So thank you guys for watching, and because today is very windy day, so if there is an inconvenience while I was recording the video, so apologize for that. So if you like the video, just like the video and subscribe to our channel for another new videos, and thank you.